In this video, I'm going to give you a practical introduction into change data capture, where we are going to build a tiny CDC listener that's going to pick up events from the Postgres write-ahead log, stream them into our .NET application, and then use that for cache warming and cache invalidation. Postgres has very rich support for replication, and it supports both physical and logical replication. We're going to rely on the write-ahead log and the Npgsql library, which allows us to stream events from the write-ahead log into our .NET application, and then this lets us react to insert, update, and delete events. So let me show you how we can wire this up inside of .NET. I'm using .NET Aspire for orchestrating my application, and I want to have a Postgres instance and a Redis instance, which is going to allow me to cache the data inside of a customer's API. Now, the first important thing to do here is to set the write-ahead log level to logical replication. And we can do this when configuring our Postgres instance by providing some additional arguments. So I have to provide them one at a time, and C is just short for command. And then we can set the write-ahead log level to logical. So now when we start our application using Aspire, it's going to spin up a Postgres instance with logical replication configured. So let's go ahead and do that. And then we're going to connect to our database and run some SQL, which is going to first of all allow us to create a table. And secondly, is going to allow us to create a publication and a replication slot. I'll explain what these are in just a moment, but for now, let's start the application. From the Aspire dashboard, you can go into your Postgres instance, and here you can find your database password. So here's the password I need to use, and I'm going to connect to this from dbeaver. So here's my database. It only has the default Postgres database and the public schema, and there are no tables inside. So let's go ahead and run some of that SQL. So I'm first going to create the customers table. It contains a bunch of columns that are related to a customer, and I also added an index on the customer email and a filter index if the customer is active. So let's execute all of this, and you can see this completes. And now if I refresh the tables, there's this one table inside. And now we get to the interesting part, which is creating our publication and then creating our replication slot. So the publication is a Postgres feature that allows us to publish updates for a specific table. So we create a publication called the customers publication for the table customers, which we have in our database. Let me go and execute this, and you can see that it's complete successfully. So that's one part of the story. Now, whenever we insert, update, or delete something in the customers table, we're going to publish events to the write-ahead log. The second missing piece here is creating a logical replication slot. This allows our application to stream write-ahead log events and also record what is the last process event so that we only process each event once. PG output is the recommended plugin that you should use when working with the write-ahead log. So you can see I created this, and now we have both our publication and the logical replication slot. So that's it as far as our database is concerned. Now we can move into our .NET app and see how we can use this for streaming write-ahead log events. And just to make things interesting, I'm going to insert a couple of customers into the customer table, and this is just going to add a couple of events into the write-ahead log that we can now read when we start our application. So let's go into our .NET app, and here we have our customers API, where I added some Aspire integrations for an Npgsql data source and the Redis distributed cache. This will allow me to use my hybrid cache as a two-level cache where I can store some customer data. I also have a hosted service, which is going to randomly either insert a customer, update a customer, or delete a customer, which I currently have commented out. And then the logic below is just generating some dummy data and running this in the database. Now, the approach I want to take is to create another background service. So let me add a new class, and I want to call this the write-ahead log streaming service. We have to implement the background service base class, and I'm going to implement the execute async method. Let's just add this as a hosted service. I'll say builder services add hosted service. We'll say write-ahead log streaming service, if I could type, and I'm going to temporarily comment out the customer CRUD service so that we don't get any confusion when we start the application. So what do we need to do to connect to the write-ahead log in Postgres? Well, I'm going to inject an iConfiguration instance and also an iLogger so that we can start writing some structured logs. So let's call this the logger, and the implementation is actually quite simple. We're going to use Npgsql, which is the popular library for working with Postgres from your .NET apps, and it already contains the required abstractions that are needed to implement this. So the first thing is opening up a connection. Now, we're not opening up a normal Npgsql connection like you're used to. Instead, we're going to open a logical replication connection. This requires a connection string, and I'm going to get this by saying configuration get connection string, and the name of my connection string is just Postgres, and this is taken care of by .NET Aspire. Now, since this supports IACing disposable, I'll also say await using. Let's also make sure that we open this connection. So I'll call connection open, pass in the cancellation token, and this is actually an async method, so be sure to await it. So now we have our connection. The next thing is our replication slot. So what we need here is an instance of the PG output replication slot. We have to provide the replication slot name, and if you recall, we call this the customer's replication slot. And finally, we can say connection start replication, and this returns an IASync enumerable containing PG output replication messages. So let me call this. The first argument is going to be our replication slot. The next argument is going to be the PG output replication options. And here we have to specify our publication name, which is the customer's publication. This also accepts the protocol version. I'll say version 4. And our next argument is going to be the cancellation token. So as I said, this returns an IASync enumerable. So I can say for each, paste all of this in, and we're going to get a message. Of course, I have to say await in front of the loop, and now I should be able to iterate over the contents of this async enumerable. So let me just align these arguments so that we can actually see everything. And indentation is always a mess when you do method calls like this, but I believe everything should be on the screen now. So then what can we do once we have the message? I'm going to just switch on the message, and depending on what the message type is, let's say if this is an insert message, then we can use the logger to log some information, and let's say insert message, and we're going to break. And I want to do the same for the other two message types that are going to be relevant for us. And these are going to be the update message and the delete message. Let's update the logs to say update message and delete message. And then the next important step after you process the message is saying connection set replication status, and you take the message, and there's this property called write-ahead log end, which basically represents a number of how far into the write-ahead log you are, and you just want to notify the connection so that it knows to move this pointer forward and that you've successfully read this message. And this also means that you won't see this message again. So let's go ahead and start the application, and I'll place a breakpoint here. And you can see that we hit our breakpoint. We're going to create a new logical replication connection, open it, create a slot, and start replication by calling the respective method. And this gives us back our first message, which is the begin message, where we are beginning a new transaction. So you can see this contains some additional properties, and essentially, since this is not a message that we are interested in, we're just going to move the write-ahead log forward and continue to the next message. And this time, the message is a relation message, so that's not what we're interested in. Then we have finally an insert message, and you can see that this also contains the contents of the row that we just inserted. So you can see we have 14 columns, and you can even get the data that's been inserted into this row. So we're just going to write the information log, and again, move the write-ahead log forward. So that's the gist of it, how you can hook into any insert, update, or delete event inside of your tables. And when you think about it, the possibilities here are quite rich. I'm going to show you a quick demo of how we can implement cache warming and cache invalidation. So let's say we add a helper method. This is going to be private async. It's going to return a task, and I'm going to call this handle insert, and it's going to accept an insert message. And I want to call this from my switch statement here. So I'll say handle insert, pass in the message instance. Of course, I have to capture the actual insert, and I have to await this. I'm going to do the same for the other two methods. So we are going to have handle update and then handle delete, and these have to accept the respective messages. So this is going to be the delete message and the update message. I have to do the same here. So let's call this update, and we're going to call handle update and handle delete and pass along the correct messages. So we're passing in update here, we'll pass in delete here, and I just have to capture this. And of course, I have to call handle delete. And then we're delegating this to our helper methods. Now from here, I'm just going to return task completed task, because I don't want to currently implement the handle delete and the handle update. And for the handle insert, I want to show you how you can extract information from the event itself. So here you can write a for each statement to access the message where you have the new row, and this allows you to access an enumerable which is going to contain your replication value. The replication value allows you to call get, and this is going to return the object representing the content in the current column. So what I'm going to do is create a dictionary here where the key is going to be a string and then the value is going to be an object. And what we want to do in the for each loop is set each column as the key. We're going to say replication value. And then we have this method called getFieldName, which is the column name. And then I can say replication value get to get the actual value. Now this is async, so I have to await it. And in my testing, I did run into this edge case, which I'm just going to drop in here. For the Boolean column, the value contains a T if this is true. And this doesn't really serialize nicely into a JSON object. So now that we have our dictionary, we can obtain a customer instance by saying JSON convert. And I'm using Newtonsoft JSON because it's more flexible to what I'm doing here. And I want to first serialize the dictionary into JSON and then use this JSON to deserialize it into a customer object. So this is what that's going to look like. And I have to make sure to pass in some JSON serializer settings where I'm going to set the contract resolver to a new default contract resolver. And I'm doing this because I want to set the naming strategy to be a new instance of the snake case naming strategy. Now let's do a null forgiving operator to make sure that this is null. And while we're here, let's also add this value to the cache. I will need another service here. So let me inject my hybrid cache instance. Let's call this cache. And then here I can finally say await cache set async. The key is going to be customers. We're going to specify the customer ID and we're just going to pass in the customer value. So let me place a breakpoint here and restart the application. And now when we run into an insert message, we're going to instantiate a new dictionary and iterate over the contents of this new row. This is going to give us a replication value. And here I can check what is the type of this value. So from the contents here, I can see that this is the ID table. Now, essentially, after I'm done with this loop, I should have 14 values in this dictionary, matching the number of columns that I have. And you can see I have all the columns in snake case as keys and then the respective values in the dictionary. So now I'm going to instantiate my customer object by serializing the dictionary into JSON and then deserializing that into the customer. I know this isn't the most efficient approach, but it's just something quick and easy that I can implement to show you how this works. And essentially we have our customer here with all of the correct data. And now I can set this in the cache. This is going to be stored in my Redis instance. And all I'm missing now is an endpoint where I can check if this actually works. So I'll go to the program file and let's say right here, I'll drop in this endpoint. The route is going to be customers/ID. And I'm just going to use hybrid cache to read this value with the same key and return whatever hybrid cache returns. And I don't want to specify a factory, although you probably want to fetch this from the database in case you get a cache miss. So the idea here is that you're probably going to query the same value that you just inserted into the database. So we are preempting this query and setting the value in the cache ahead of time. So let me restart the application again. I hit my breakpoint here to set the value in the cache, and I'm just going to store the customer ID that I want to use when I send my database request. So I'll press continue here and go into Postman. And inside of Postman, I'm going to send a request to our API endpoint. And you can see we hit our breakpoint right away. And if I execute this, we get back the same customer we cached in Redis using hybrid cache. Now this is the same value that we just added to the cache from our write-ahead log service. So I can press continue and we should get a response back in Postman as you can see here. And then we can continue implementing the other missing features, which is updating the cache in case of an update event or invalidating the cache in case of a delete event. Now what's missing here is some proper error handling, which we could add next. And then I want to briefly discuss another interesting use case for this, which is basically implementing a streaming Outbox processor. You're going to create a background service that's going to use logical replication to react whenever there's an insert into the Outbox table, and then we're going to take that message and publish it to a queue. This is pretty much how change data capture works with something like Debezium. And it could be a nice improvement compared to the typical polling implementation where you query for the latest unprocessed messages from the Outbox table every couple of seconds. If there is interest in demonstrating this, let me know in the comments below and I'll consider if I should demonstrate this in a future video. If you want to learn how you can implement the Outbox pattern from scratch and what problems it solves, I highly recommend checking out this video next. Make sure to smash the like button for the YouTube algorithm so that this gets recommended to more .NET developers. And until next time, stay awesome.